Hi students, today we are going to see about Biot-Savarts law. So what is Biot-Savarts law? So using Biot-Savarts law, we are going to find out the magnetic field density or magnetic field of a current carrying conductor. So how to find the magnetic field of a current carrying conductor? And thereby we will define what is Biot-Savarts law. So consider a conductor that is carrying a current I, okay, and we are going to find out the magnetic field B for this current carrying conductor. So first let us define what is Biot-Savarts law. So Biot-Savarts law states that the magnetic field is directly proportional to the current of the differential element dl and sine of the angle theta divided by r square. So let me explain what is this. Conductor is carrying current, magnetic field will be rotating this. Here we are going to find out the magnetic field at a point P. We are going to find out the magnetic field at a point P, and we are considering a differential element dl, which is called as an infinitesimal element. That means a very small current element which is carrying a current I. So we all know that only moving charges constitute magnetic field, but electric field is constituted by static charges, but magnetic field is only constituted by moving charges, that is current. So current is necessary for magnetic field. So this differential element is having a current I, and that is total current is I into dl, and we are taking an axis, that is the axis of the current element, and this angle as theta, and if that is the case, then the magnetic field at this point P can be calculated using this formula, and this distance is called r. So I into dl sine theta divided by r square. So the magnetic field is directly proportional to the current, angle between the current element and the position vector, and inversely proportional to the distance between the current element and the point which we are considering. And this is called the Biot-Savarts law. And when you equate it, you have to apply the proportionality constant, which is called mu naught divided by 4 pi into I dl sine theta divided by r square. What is mu naught? It is the permeability, and 4 pi. What the value of mu naught divided by 4 pi is equal to 10 raised to minus 7. Okay, and this is called the proportionality constant, and this is called Biot-Savarts law. So Biot-Savarts law is only used to find out the magnetic field at a distance P from a current element. And what are the things that is required? We want to know the current, we want to know the differential length, and the distance between these 2 points, and the angle between the point of consideration and the current element axis. Now, since an angle is considered here and it is called the sine theta, we all know that sine 0 is 0 degree and sine pi by 2 is 1. So sine 0 is 0 and sine pi by 2 is 1. or we can say this as sine 90 degrees equal to 1. And now what happens? If the point of consideration is along the current element, so if the point of consideration, that is the point at which we are finding the magnetic field, is along the direction of the current element, then the value of theta will become 0. Then the value of theta becomes 0, and in that case there is no magnetic field. And we get the maximum when the point of consideration is perpendicular to that of the current element. So only in perpendicular cases we get the maximum value of magnetic field. So this is Biot-Savarts law. So Biot-Savarts law is simply used to find out the magnetic field of a current carrying element. Now I will relate this magnetic field with that of the electric field. So you all know that electric field is represented by E and magnetic field is represented by B. Electric field is E and magnetic field is related by B. So what is the difference between electric field and magnetic field? Electric field is because of static charge and magnetic field is because of moving charge. So electric field is because of static charge and magnetic field is because of moving charge. And what is the formula to find electric field? That is equal to Q divided by 4 pi epsilon naught into R square. Here the magnetic field is equal to I dl sine theta mu naught divided by 4 pi divided by R square. So electric field is because of static charge, magnetic field because of moving charge, and the formula to find is more or less similar because both are inversely proportional to the distance r. And if you see, the direction of the electric field is along the charge, but the direction of electric field is along the charge, but here the direction is perpendicular to the charge. Okay, so I hope that it is clear for you. So I am relating the electric field as well as the magnetic field. What about electric field? It is because of static charge, but magnetic field is because of moving charge. If there is no moving charge, there is no magnetic field. The electric field E is given by Q divided by 4 pi epsilon naught into R squared, but B is equal to mu by 4 pi I dl sine theta divided by R squared. So here it does not depends on angle, here it depends on angle. Both are inversely proportional to R squared. And the direction of the electric field is along the charge and the direction of magnetic field is perpendicular to the charge. And I hope that Biot-Savarts law is very clear for you. Thank you for watching. Please subscribe our channel for more videos. Thank you. This is Arun. Bye.